Welcome, seventh grade. All right, today we're talking about equivalent fractions and mixed numbers. Hopefully, these sound kind of familiar. The reason we did GCF, greatest common factor, and least common multiple, because they will help us a lot when we are trying to come up with equivalent fractions and mixed numbers. All right, today I have a name for something, and I'm going to be asking you to use that. You may have already kind of used it with Mrs. Letcher. All right, name the common factor for each pair. 5 and 10, they would have 5 as a possible answer. Okay. 9 and 12, 3 would be a possible answer. 20 and 24, you could have 4. You could have 6. Or you could even have 12 as a common factor. All right. Then for these, 10 and 14, you would have 2 as a common factor. 6 and 8, you would have 2. And 8 and 15, I don't see any common factors but 1. All right. Ladies and gentlemen, the problem of the day was solved by Grayson. Good job, sir. All right. Learn to identify, write, and convert between equivalent fractions and mixed numbers. So we're going to go from mixed numbers to equivalent fractions and back. Today is about multiplying and adding and dividing. All right. Equivalent fractions, relatively prime are two important words. In some recipes, the amount of ingredients are given as fractions, and sometimes those fractions do not equal the fractions on a measuring cup. Knowing how fractions relate to each other can be very helpful. These squares, or these rectangles, if you look at all of them, are the same size if you look at the very outside. They're all the same size. Yet we've broken them down into different size pieces. We've broken this far one to the left into 5 pieces. Oh, that's fifths. We've broken this one down into 10 pieces. Oh, that's tenths. And we've broken this one on the far right into 25 pieces. That's 25ths. All right? Yet, they can be the same. If we have 1/5 and 2/10, didn't I just cover up the same amount of area? Oh, and we look, times 2 over 2, that makes it into 2/10. If I do that here, that's 5/5. If I would take 1/5 times 5 over 5, I would get 5/25. These are all equivalent fractions because they represent the same amount, just with different numbers. All right? So different fractions can name the same number. They would like to put in their little plug too. So here we go. All right? They covered 3 of the 5 parts. That's 3/5. They covered 6 of the 10 parts. That's 6/10. And they covered 15 of the 25 parts. That's 15 over 25. All of these are equal, and you can see by the pictures they cover the same amount of area. It's just I chose to break this candy bar, one right here, into 3 pieces, or 5 pieces, and I gave you 3. This candy bar I chose to break into 10 pieces. I gave you 6. And this candy bar I chose to break into 15 or 25 pieces, and I gave you 15 of them. You got the same size piece, or the same amount, but you just got them in different sizes, okay? Now, when we look at these, you have been doing this for a long time, and I'm surely hoping that you can do it again, all right? In the diagram, 3/5 equals 6/10 equals 15/25. These are called equivalent fractions because they are different expressions for the same non-zero number. They're different ways to show the same thing, is literally what they're saying. All right? To create fractions equivalent to a given fraction, multiply or divide the numerator and the denominator by the same number. Key thing. Multiply or divide the numerator and denominator by the same number. That's where you get a fraction like 2 over 2, 3 over 3, 17 over 17. All of those are what I call a fancy one, because 3 divided by 3 is 1. 2 divided by 2 is 1. 17 divided by 17, 1. All right? So you've got that to use. That's your way to make equivalent fractions. So find two fractions equivalent to 5/7. Wow, we did a lot more than 2. All right? So you can choose any number in the world to make an equivalent fraction. So like if I wanted to, I could choose to take this up by 2 over 2. 2 over 2 is just a fancy one. It doesn't really change anything. To make 10 over 14. All right. Now, if I had not chose to use 2 over 2, I could have used 100 over 100 and got 500 over 700. They're both equivalent fractions to 5/7. Another thing I could have done, I could have done 5 over 5. And I could have got 25 over 35, another equivalent fraction. As long as the fraction you multiply by has the same two numbers, one as the numerator, one as the denominator, you will get an equivalent fraction. All right? You can't help but come up with one. All right? So let's move on. They got 10/14. They got 15 over 21. They choose to use 3 over 3. And there are an endless number of other ones. Now, it works the other way as well. So, last time, we had 6/12 and we multiplied. You can also do this to reduce fractions. If I choose to divide by 2 over 2, that is 3/6. I get a very useful answer. Now, many of you are probably already saying, Mr. Palm, you should have done divide by 6 over 6. 6 divided by 6, 1. 12 divided by 6, 2. I reduced it down to 1/2. So you can divide by the same number over the same number, or you can multiply by the same number over the same number. Or you can choose to do each. So these are equivalent fractions. They both represent 6/12. Or if I wanted to get crazy and I wanted to go, let's do 2 over 2, I could get 12 over 24. All of these in one way or another represent 1/2. All right? So you can multiply by the same number over the same number or divide by the same number over the same number. Dividing does have its limitations. Both numbers should be divisible by the number you divide by. Let's see which ones they used. I'm thinking you guys are getting this. I can hopefully see it in your minds. All right. And those are two different ways. Look, you can multiply and get an equivalent fraction, or you can divide and get an equivalent fraction. All right. Now, a fraction is in simplest form when the numerator and denominator are relatively prime. Relatively prime numbers have no common factors other than 1. So if we look at what I had up here originally, 8 and 15, well, 8 and 15 don't have any common factors, so they're relatively prime. That is in simplest form. All right, 6/7. They are relatively prime. That's simplest form. All right, so let's look here. Write the fraction 18 over 24 in simplest form. So 18 over 24. Sometimes you take big steps and other times we take small steps. I'm going to show you how to do this multiple ways. Okay? So 18 over 24, I could see what number goes into both 18 and 24. I see that 2 will go into both. 2 over 2, that's a fancy one. 18 divided by 2 is 9. 24 divided by 2 is 12. And then I can see, 3 will go into each of these. So if I divide this by 3, and 3. 9 divided by 3 is 3. 12 divided by 3 is 4. There's no smaller numbers. There's no common factors anymore. So 3/4 is in simplest form. Now, some of you are saying, oh, Mr. Palm, there's a faster way to do it. I'm glad you saw that. I could divide by 6 over 6. Because I see 6 will divide evenly into 18 and 24. 18 divided by 6 is 3. 24 divided by 6 is 4. I'm to the simplest form again. It does not matter if you do it in one step and get to 3/4, or if it takes you 2 steps and you get to 3/4. You got to 3/4. So you can take small steps and use smaller numbers, or if you see the bigger numbers are available to divide down, you can use them. They will get you the same answer no matter what. All right? Now, some people are going to say you can use the GCF. Well, that is something you can look at. That would be 6. And that was the bigger number that we did. Now, I wouldn't go through all the trouble of writing out the GCF. If you want to, you can. All right? But you've been reducing fractions for a long time. Just go ahead and realize and skip to what you know that goes into both of them. All right? Here, I'm going to get rid of that. We can see, 15 is divisible by 15, and so is 45. We get down to 1/3, simplest form. Now, it would have not hurt anything if we would have said 15 over 45. You know what? They both end with a 5, so I know they're divisible by 5. 5 over 5 is a fancy one. Then we get 3 over 15. Oh, I see. Those are both divisible by 3. And we get 1/5. Oh, excuse me. Oh, that is where I went wrong. This should have been 9. 45 divided by 9. See, I make mistakes too. You already knew that, though. We get 1/3, which is the same if you don't make a mistake. All right? So they do their math. Yes, they found the greatest common factor is 15, and you can divide by that. If you'd like to just do it step by step, no problem there, and we can solve it in 2 or 3 steps or 1 step, whichever one happens. Determine whether the fractions in each pair are equivalent. Oh, are they equivalent? 4/6 and 28/42. I can do one of 2 things. I can either take this side and make it bigger, where it's 42 as the denominator, or I can make this side and try to reduce it and make it where it's 6. All right? I like to multiply instead of divide, so if I'm thinking here, 42 will go, or 6 will go into 42 7 times. So if we do 7 over 7, 4 times 7, 28. 6 times 7, 42. They are the same. They are the same. All right? They are equivalent. Yes, happy day. They are equivalent. All right? Both fractions can be rewritten. All right? They took it down to 2/3, and then they reduced this one down to simplest form, and they got 2/3. That is another way to see that they use their division to get them to simplest form. But what you really want to do is you want to get the denominators that are the same, then you can compare the numerators to see if they're equivalent or not. All right? So here we are again. We look here. 10 will not go into 25. So that doesn't necessarily mean that nothing's good. This would be a case where you would want to take it down to simplest form. All right? I know I can divide each side by 2, and I get 3/5. Okay? I know then I need to get this to 5. So if I divide 25 by 5 and 5 on top, all right, that would be 4/5. I took them both down to simplest form because then I've got the same denominator and I can compare them. If you look and the denominators are not compatible where I can turn one into the other, then I would go down to simplest form and compare them that way. All right, here's what they do. All right, The first way we did it, that was because one was a factor of the other. This time that didn't happen. All right, so 6/10. Oh, they even took another approach. They chose to say 10 will go into 50, 25 will go into 50. So we get 30 over 50, and we get 40 over 50. Watch what happens if you do this, though. 3/5, 4/5. Oh. Either way works. We just need to get their denominators the same. Then you can easily compare them and see if they're equivalent. Okay? So now we are going to see, is this 5/8 or 8/5 equivalent to 1 3/8? They're telling us, yes, it is. But how did I get from one to the other? All right. 8/5 is an improper fraction. That means the numerator is bigger than the denominator. Okay? This is a mixed number, 1 3/5. It contains both a whole number, the 1, and a fraction, the 3/5. An improper fraction is a fraction where the numerator is more than or equal to the denominator. So now we're going to work on taking and going from improper fractions to mixed numbers and mixed numbers to improper fractions. With improper fractions, this bar right here means division. So that means 13, the numerator, is divided by 5, the denominator. You go till you get to the decimal. Decimal's right here. 5 will go into 15 or 13 2 times. That's 10. There's a 3. The number on top, that's your whole number. The 5 stays your denominator. And the number down here is your new numerator. 2 3/5. So, number on top, that's your whole number. Number on bottom, that's your numerator. And your denominator, notice, stays the same. Okay? To go the other way, we use something I call the triangle method. 3 times 7, 21. 21 plus 2, 23. See how I kind of made the triangle there? So we would get 23 over 3. That would be our improper fraction by using the triangle, doing air quotes, method. All right? Let's go ahead and show you how they do it so you can get their sense of things. First, divide the numerator by the denominator. I said that. When you do that, you get 2 3/5. All right? First, multiply the denominator and whole number, then add the numerator. When you do that, you get 23 over 3. You guys are probably getting pretty good at these. I remember you even talking about it already. So this one means division. So 15, the numerator, is divided by 6, the denominator. That will be our denominator in the other problem. Make sure you know where the decimal is so you know where to stop. 6 goes into 15 twice. That is 12. That's 3. We're at the decimal, so we stop. So 2 is our whole number. The number on top is always the whole number. This, 6 and 6, that remains the denominator, always. The number here down at the bottom, that is your new numerator. 2 3/6, or 2 1/2 if I reduce this fraction. Okay? So, on the bottom here, use that triangle method. 8 times 3, 24, plus 1, 25 over 3. Oh, let me move these things so you can see their work. All right, they just kind of show you the answer. That's why I don't really care for what they did. And we just kind of go with what I did. 2 3/6, or there's your 2 1/2. Triangle method, they get 25 over 3. All right, I think you guys are all ready. God's blessings on your lesson.